Everyone. In this video tutorial I'm going to discuss about adders. So what is an adder? So adder is referred to some kind of plan which can add 2 bits or a 3 bit like that. So let me explain you the first what is adder. An adder is a digital circuit that performs addition of numbers. In many computers and other kinds of processors, adders are used in the ALU. Right now, think in binary addition, we have to add 1 and 0. The output will be 1, right? There is no problem. But there are cases like this. If you add 1 and 1, we know in binary the answer is 0, and we will carry 1 to the forward. We will carry this one to the forward. So how to represent this one? It's difficult. So when talking about these adders, there are two type of adders, saying half adder. For the half adder we have only 2 inputs, right? And there's a full adder. In full adder we have 3 inputs. In half adders we have 2 inputs and we have 2 outputs. In full adder we have 3 inputs and we have 2 outputs, right? Let me explain you the half adder again. So in this one, this is the truth table actually, and you can see if 0 and 0 are added, you will get 0. 0 plus 1, 1. 1 plus 0, 1. 1 plus 1 is 0, and there's another one is remaining. That remaining one is the carrier one. So this column represent XOR gate, outputs of a XOR gate, and this column represent AND gate. You can see 0 into 0 it's 0, 0 into 1 0, 1 into 0 it's also 0 here, 1 into 1 only is the only output. So this is the logic gate which comes with the half adder. So let me show you my simulation. My simulation is like this using Logician. So let me show you how to simulate this one using Logician. Here you can see my half adder in the canvas. So this is the truth table that you have seen in my note actually. So this is the situation. These items are okay. If you add 0 0, no problem, no carry will be there. But when you are adding 1 and 1, there will be a carry. So think if we add 1 and 1, we have 2 as the answer. So that 2 I am going to represent by these 2 tally marks. If we mark like this, so if I group this one by 2 groups and 2 groups like this, group of 2, I can mark one group from here, and I have nothing to mark anything, no any other groups. So one group is okay, one group is the carrier, and the remaining I have nothing, no 0, no. So it's the sum. So I can now I'm gonna input actually this logic gates to this canvas, and I'm gonna start simulation. You have to take XOR gate from here. I'll place it here. I'll be reducing the number of inputs to 2. Then I need another AND gate. So because you can say this column represent XOR gate and this column represent AND gate. Then I will be reducing the number of inputs from here to 2. Then I will be wiring this circuit. The thing is one input come like this. We should mark the input as 2. One wiring like this, and the other wiring is from here. and the outputs are like this. So let me label the inputs, add input pins. I have added input pins here. I'm going to fasten these two ends, and I'm going to show you the results from this pin. And I need another pin in here. Okay, now actually this is my sum, right? Because sum column represent XOR gate. From the XOR gate I will get the result as sum. So I will label this one as sum and this one carry. Let me name this one as A, this input as B. This is my logic gate, which comprises XOR gate and AND gate for half adder. Similarly, I can construct this using this symbol. From arithmetic option you can take this adder also. Rather than from logic gates I can use like this. Take this adder circuit, double click on that, reduce the number of bits to 1 because we are transferring 1 bit at time. So then what you have to do is this is your A and B, and then this is C out, or else the carrier bit, and this represents the sum. I need another pin like this. I'm gonna label these two, this as carrier and this as the sum. This is my sum out, and inputs are like this. My circuit is now completed, so I can start simulation. I should prior to start simulation I should name this as these inputs. Okay, now you can see my circuits. These both circuits are same. Rather than is using logic gates, I can use this circuit also. So you can see this circuit is equivalent to this circuit. So sum is here, sum output here, sum output here, carry output is here, carry output is here. So let me start the simulation. So if I check this hand tool, and for the input AB 0 0 0 0 0 0, the sum and the carrier will be 0 and 0. Sum and the carrier will be 0 0. It's okay, it's satisfied. Now let me change the values. A0 B1, A0 B1. A is active low, B is active high. A is active low, B is active high. So pay attention to the result from the both circuits and to the truth table. So from the first circuit we have 1 and 0. 1 is the sum, 0 is the carrier. 1 and 0 we have, 1 and 0 we have. 1 and 0 is the out. So let me change to this stage. A is 1, B is 0, 1 0 combination. 1 0. This one is 1 0. What we get as the answer is 1 and 0, 1 and 0. Answer is correct. So let me go to the last stage, is the interesting part, right? Interesting part. So both inputs are active high 1 1. When 1 1 is the input, we will get the summation as 0 and the carry as 1. We will get summation as 0, carry as the 1. You can see it from. So this is the simulation of half adder. So let me I hope all you understood this scenario within the half adder. So it is used only to add these two digits. This circuit is used to add only these two digits, 0 and 0 digit, this digit and this digit. So you will be adding only these two. In next, I will be discussing the full adder. So let me move to my note. This is my simulation. This is the full adder. In full adder, we have three inputs, A, B, and C. Actually, C. Regarding this one, we have summation column and the output also. You can see one XOR gate, another XOR gate, and two AND gates and an OR gate. So we'll be taking the output from one here, another output from here. Inputs are comes like this. Initially what we had was we had only two inputs. In this one we have three inputs. Let me move on to my circuit now. Here you can see my full ladder truth table, which you saw on my Word document. So let me draw my logic gate first. So I need OR gates. You saw that there are two OR gates, two XOR gates, right? Here's a one XOR gate. I need another XOR gate. I need two AND gates. And another OR gate. So every input should be 2. Each and every gate, the input should be 2, because we have here two inputs. I'm changing the number of inputs to 2. So now my components are correct. So initially there will be lines like this from input A and input B. Okay, then this output will come as input to this the another OR gate, and I will have the carry bit from here. Similarly, this is okay. Then another output will, this output is my the summation output. This is one output and this is the other output. So these two will be get connected to this one, and these two inputs will be connected to A and B. Right, I should take another input from here to feed to this AND gate, and this one I need to connect it to the clock, not the clock, the carrier button. Right, so now my circuit is completed. I need to add input buttons. I am adding these input buttons now. Okay, and then outputs, I'm gonna take the outputs, I'm gonna display the outputs. So I'm gonna add another pin to here to take the output, and I need another pin to here. So I will label these inputs as A, B, C. Here we have A, here we have B, and here we have C in. Right, so my circuit is now almost completed. What I have to do is I need to name my outputs. So this is the sum output, this is the carry out. Right, my circuit is now almost completed. It's ready to simulate. With this, I would like to show you this adder. In the arithmetic option there is this adder option. You can take this adder option and you can place it here. By using that adder option, you can do the same thing. Rather than having these many logic gates, you can use this one as the simple gate. Right, we have to double click on that, make the number of bits as 1, and then we have 3 inputs, right? A, B and C. So I'm going to do the wiring. This is my C input, this is my B input, this is my A input. So I'm going to add pins to these inputs. One pin here, another pin here, and another pin in here. Right, then I can take the outputs from here. The summation I will get from here, and the carrier I will get from here. Summation from here, and I need to take the carrier, so I will be taking it to here. I will be changing the direction to south, heading direction. You can label these items from here also. Right, see now this is my sum. These are my inputs. This is C in output, C in actually, or not output. You have 3 now here, 1 and another one, right? So what happened here is you have 1 here and another 1 here. So I have marked it using tally marks. One tally mark, another tally mark, another tally mark. But if I tell you to just group this by 2, if you group this by 2 groups, this is a one group and this is the remaining one. There is nothing to remain. So what you get is after inputting these 3 values, you will get this from this logic circuit. It will be calculated. So 2 groups, it means a pair of, there are 1 pair and 1 is remaining. So 1 pair is this carry. 1 pair is represented by this carry, and then this one is the summation. So this the 2 tally marks will come here, and this one here, and So this will represent as 1 and 1. This is the scenario of full ladder. So hope you understand everything. So I'll be meeting you from another tutorial. So thank you all. So here I have marked every inputs and outputs. So you can see I have marked this one as C in and B and A. This is my A and B output. Now the circuit is almost completed. Now I'm going to start this simulation process. So these both two circuits are the same circuits. Rather than drawing logic gates, I can use this single component of circuit for adder. So let me start the simulation. So you can see for the combination ABC 0, A is 0, B is 0, C is 0. For the ABC combination 0 0 0 combination, the output will be 0 and 0. You can see ABC 0 0 0, output will be 0 0. ABC combination 0, output will be 0. So let me move on to the second row. The combination is 0 0 1 combination, A0 B0 C1, A0 B0 C1, A0 B0 okay C1. So in this combination we get 1 and 0, 1 and 0 as the output, 1 and 0 correct. For this row, from the both circuits we will get as 1 and 0. Now the next combination is 0 1 0, 0 1 0, active low, active high, active low, active low, active high, active low, 0 1 0. Then we will get the output as 1 and 0, 1 and 0, correct. Then the combination 0 1 1, 0 1 1, 0 1 1. We have output as 0 1 0 1, 0 1, correct. Then the input as 1 0 0, 1 0 0, 1 0 0, correct. Then the outputs are 1 and 0, 1 and 0, correct. So let me move on to this one, 1 0 1, 1 0 1, 1 0 1, correct. Outputs are 0 1 0 1, 0 1, correct. For the inputs 1 0 1, outputs are 0 1 0 1, correct. Let me move on to the last part. This is also the same, 1 1 1 as the input, all are active high. If all the things are active high, you will get as 1 and 1 as the output. So from these both two circuits, it's confirmed now. So this is what happened when you use 3 bits input to a full ladder. This is we call as a full ladder. So if you input 3 bits, those 3 bits converted and it is added to these circuits, and then it will result at 1 and 1 here. Actually this represent the carry is 1. It means there's 2 inside of this. The number is 2 is hidden inside of this, and sum is 1. So let me show you from now you have here one input from here, one input from here, one input from here. We have you have now one, sorry, I will mark it from telemarks. 1 2 inputs you have like this, altogether 3, no, 1 2 3. So if I tell you to group pairs, group by 2 each pairs, so what you have to do is you have one pair here and another pair here. There's no other pair, there is remaining only one. So what will happen is this 2 group is another 1 group, and you will be remaining 1. If the thing is, if you add this thing, right, so this 1 is this grouped 1, it is the carry, this is the carrier 1, and this is the summation 1. So this is the simulation of full ladder using the logic gates and also from the circuit. Hope you all understood everything, how to use this full ladder and half ladder. So basically we use these adders in arithmetic and logic units in order to do the calculation parts. So we will be meet from another tutorial. Until then, thank you all.